Transactions play an important role in ensuring the integrity of our data. Datastore transactions are atomic, which means every operation succeeds or none do. To demonstrate their use, let's implement a simple registration method, which we will use to register new users. To start with, we'll create a new user service. We'll need to inject our user repository, which will give us access to the user entities, and now operate our registration method. So first thing that we want to do probably is check that a user with the given email hasn't already registered. So let's add a check in there for that. We'll just create our exception class. Thunder has a handy base exception class which provides a couple of useful constructors, particularly the one with that takes a string format, so we'll just use that. So to the uninitiated, this seems perfectly fine, but there's a rather large problem lurking in this method. In the last video, I mentioned that fetching by ID is a strongly consistent operation, while queries are weakly consistent. Since get by email is backed by a query, as we can see here, a race condition exists where multiple users may register with the same email address. Fortunately, there's a relatively simple, if not verbose fix, which takes advantage of the fact that lookups via keys have strong consistency guarantees. The solution will also require a transaction to be robust. So to start with, we're going to define a new entity which makes the mapping between an email and a user. Got all the same annotations as before. So you'll notice that I'm using the email as the ID field. And I realize I said in a previous video that natural keys generally make poor choices for IDs, but in this case it's necessary to enforce uniqueness. There's really no other way. It's also less of an issue in this scenario because we won't be referencing these entities widely through our app's data model. They exist solely for the purpose of performing consistent lookups of users by email. So we'll add in all our usual constructors. Now for the keen-eyed amongst you, you'll notice that I'm using something which we haven't seen before, which is a ref. So a ref is a wrapper for an entity that will actually store the key of user, a reference to it, within this class. It takes care of all that serialization for you. It's handy because refs provide a means to load the actual user entity inline. So you'll see here when I add the getters how that actually comes about, or how that plays. But you'll notice that in the constructor, I'm using this ref.create to take an existing user entity and then transform it into a ref, which we then store as our user field. To an external consumer, they'll only ever see user objects being returned. So let's just provide the getters for these things. This is going to be an immutable object, so we don't really provide setters. It's a set one-time thing. Now, with refs, we can do refs user.get. It does create a scenario though where you can get a null pointer exception if user was passed in as null. One solution is we could do a null check here on the email user mapping itself. But just to be extra safe, what we tend to do is use this refs unref method, which has an implicit null check in it. And will actually calls the get. So you can see here, does the null check, returns null if it is null, or calls get. It's just a handy little method, good to get in the habit of using. We'll also provide our equals and hash code methods, much in line with what we've done previously. Again, we're using the email field because it is the ID, and these equals and hash code methods should, the contract with it should be that things with equal IDs are equal, being an entity. So now our entity's built, we'll repeat the pattern that we've seen before, which is to build a repository for it. So we'll call it email user mapping repository. Gotta love verbose class names. Again, it's a string repository and it's generic, so we give it the type of the model that we're using, or the entity, I should say. Once again, we don't need a search config at this point. And this repository just needs basic CRUD methods. We'll need to make sure, as always, that we register our entity with Objectify. And we'll also inject our repository into Thunder. Oops, it should be at the top. With those two things in place, we'll now update our user service register method to perform the check using the email mapping repository. We'll inject that. We'll change this method here. So this is already looking better. We can now perform a lookup against the email with strong consistency guarantees. We're not quite done yet though. We need to persist a mapping entity to reflect the new registration. So naively, we might do something like this. But what happens if something fails in between calls to persist the user in the mapping? So roughly around here. Failures can occur for a large number of reasons that have nothing to do with your code, including data store timeouts, network errors, instance failures, etc. In that event, we may well end up with a new user being persisted, but without a corresponding mapping entry, meaning that subsequent registration could in fact still register a duplicate account. So that kind of defeats the purpose. Transactions remove the possibility of leaving the data store in an inconsistent state. So let's see how our code looks when wrapped inside a transaction. For this, we use a objectify method here. So it looks like this. And we use these blocks, these work blocks. It's effectively a lambda. We'll just need to make email final, since we're using it inside an anonymous class. So it's really important that the work performed inside a transaction must be idempotent. Transactions can retry for a number of reasons, most commonly concurrent modification. This is because Datastore employs optimistic locking. So your work block should produce the same result no matter how many times it's run. Keeping this in mind, it's worth pointing out there's still an issue with our transaction. Remember that our user ID is actually generated in the constructor here. This means the transaction is not idempotent, as the ID would be regenerated with each try. To achieve idempotency, we'd have to remove the creation of the user outside the transaction. So let's quickly do that. So with that moved outside, we've now wrapped our new user registration inside a transaction, and we've ensured that it's idempotent by creating the user outside of the transaction. So every time this is attempted, it will always be attempted with the same set of data. So we should get the same outcome. It shouldn't matter how many times this is run. In this video, we've covered the basics of transactions and touched on some potential pitfalls owing to the eventually consistent nature of the data store. As always, I recommend you check out the Objectify docs on the topic using the link below.